Learners, let us see how to calculate the velocity of sound through a wire using sonometer. So here I have taken a sonometer with a steel wire which is tied across a pulley, and the other end of the string is having a load of 3.5 kg. Next, a piece of paper has to be hanged between two movable knife edges. Tuning fork of 288 Hz is used for this experiment. Going to strike the tuning fork in a rubber cock and place it near to the string. If the resonance condition arrives, means it begins to vibrate until the both the knife edges can be moved to get the resonance condition. See here, the paper gets vibrates now. So to get an exact value, once again I am moving the knife edge. Now you can notice the resonance condition arrives, and due to that the paper piece fell down. So the corresponding distance between the movable bridges has to be noted. Knife edge is near to 70, and the another one is moreover 88.8 centimeter. So difference has to be found out between these two values. Observatory part, material used has to be mentioned, and the tuning fork value, then length of the vibrating segment. So for steel wire, the length of the vibrating segment value is 18.6. So it is written in the unit of centimeter. Whereas frequency, as I already said, it is of 288 Hertz. So the tuning fork. So mass has also been mentioned here, which is of 3.5 kg. So far steel has been used, and next aluminum string has to be changed for the same procedure, and the mass is going to be same as like 3.5 kg. So the corresponding length of the vibrating segment has to be noticed as like previous procedure. The distance between the knife edges has to be measured. First one is 67.8 and another one is nearly 80.6. So 80.6 has to be mentioned here. Subtracting it with 67.8, which gives 12.8 centimeter. So this is the length of the vibrating segment for aluminium. So for steel 18.6 and aluminium is 12.8. So finally we have to find out the velocity of sound. So formula for it is V is equal to F lambda. So already we have noted frequency, length of the vibrating segment, frequency in terms of hertz or per second, and length in centimeter. Length of the vibrating segment is mentioned in the letter lambda. Is wavelength. So for steel 5356.8 and aluminum it is 3686.4. Both are correlated with the standard values. Thank you.